Have you ever wondered how your refrigerator or air conditioner works? It's a fascinating dance of science, specifically the principle of thermodynamics. At the heart of these cooling wizards is a substance called a refrigerant. This refrigerant, with its low boiling point, is the unsung hero of our comfort, absorbing heat from our surroundings and releasing it elsewhere. It's like a magical heat sponge, making our homes and food cool even on the hottest days. So let's dive deeper into this cooling magic that makes our lives so much more comfortable. A scene script. Imagine opening your refrigerator. You feel the cool air, but have you ever thought about what's happening behind the scenes? Now, let's take a journey to the heart of your refrigerator. Our guide for this journey is a substance with a low boiling point, known as the refrigerant. It starts its journey in the evaporator unit, where it evaporates and absorbs heat from the refrigerator's interior. This is the magic that cools down your food and drinks. But the journey doesn't stop there. The vaporized refrigerant heads to the compressor, which is like a pressure cooker for the refrigerant. As the compressor compresses the gas, its temperature and pressure rise significantly. Now we have a hot, high-pressure gas, and it's ready to go on the next part of its journey. It flows through the condenser coils, which are like the radiator of a car. As the gas flows through these coils, it releases its heat into the external environment. This is why the back of your fridge feels warm. At the end of this journey, the refrigerant condenses back into a liquid, ready to start the cycle all over again. This cycle of evaporation, compression, condensation, and return is constantly happening behind the scenes in your refrigerator. That's the journey your refrigerator goes on every time it cools down your favorite drinks and food. Now, think about your air conditioner. It follows a similar process, but its mission is a little different. You see, an air conditioner's job is not just to cool the air, but also to dehumidify it, creating a comfortable environment in your room. To do this, it uses two main components: an evaporator coil located inside the indoor unit and a condenser coil in the outdoor unit. The process starts with the evaporator coil. The refrigerant inside this coil absorbs the heat from the indoor air, causing it to evaporate. This transformation from a low-pressure gas to a high-pressure gas is crucial in the cooling process. Next, the high-pressure gas is sent to the compressor. Here, the gas is compressed, which further increases its temperature. But don't worry, this hot gas won't heat up your room. That's where the condenser coil comes into play. Located in the outdoor unit, the condenser coil acts like a heat exchanger. It releases the heat carried by the refrigerant into the outside air. As it loses heat, the refrigerant condenses back into a liquid, ready to start the cycle all over again. And there you have it. The heat from your room is effectively transferred outside, leaving you with a cool and comfortable space. So that's how your air conditioner makes those hot summer days bearable. Scene script. Even though refrigerators and air conditioners serve different purposes, they both rely on the same principle. This principle is rooted in the laws of thermodynamics, where heat naturally flows from a hot object to a cold one. Both appliances ingeniously manipulate this natural process using a refrigerant, a substance that boils at an unusually low temperature. In a refrigerator, the refrigerant starts off inside the evaporator unit's coils. Here, it absorbs heat from the interior of the fridge, causing it to evaporate. Then, the compressor steps in, compressing this vaporized refrigerant, which results in a rise in its temperature and pressure. This hot, high-pressure gas then travels through the condenser coils, releasing the absorbed heat into the environment. After this, the refrigerant condenses back into a liquid, ready to repeat the cycle all over again. An air conditioner follows a similar process, but with a slight twist. It has an evaporator coil inside the indoor unit, which absorbs heat from the room's air, and a condenser coil in the outdoor unit, which releases the heat outside. This clever design both cools and dehumidifies the air in a room, providing that refreshing feel on a hot day. So, while refrigerators and air conditioners might seem like magic, they're really just examples of science at its best. Both rely on the transfer of heat through the phases of the refrigerant to maintain a cool environment inside while expelling heat outside. And that, my friends, is the cool science behind your refrigerator and air conditioner.